Hello, class. All right, I wanted to revisit this troubleshooting lecture that we attempted today, and I was having so many problems. So we're going to start again. So I got a different breadboard. Something was going on with the breadboard that I had in class today. So we are just going to switch breadboards and we're going to start again. Okay, something also was wrong with the power supply that I had before. So now I am using the Arduino power supply. Okay, I have put a red lead in the 5 volts output from the Arduino, and then a black wire from the ground, okay, in the Arduino, okay, and I have set up 2 buses on my breadboard. This is my power bus, the 5 volts. This is my ground, 0 volts. Okay, so let's look at our circuit. Okay, so here is our circuit. We have a NAND gate connected to an inverter, which should actually just give us an AND function, right? So if we look at the truth table, 0, if I get 2 zeros as an input, I get an output as a 0. If I have a 0 and a 1 as an input, I get output as a 0. If I have a 1 and a 0 as an input, I get a 0 as an output. The only time I get a 1 as my output is if both inputs are 1. Okay, so we're going to build this circuit and then test the truth table. So the first thing we are going to do is to test out the 7400, the name well. Okay, so this is my 7400 right here. Okay, this is my 7400 right here. Okay, so first of all, we are going to test out the 7400. Okay, so the first thing we always have to do is power the chip and ground the chip. So power is pin 14. So I'm going to put power to pin 14. Okay, ground is pin 7. So I will ground pin 7. Okay. All right, so now my inputs I'm going to use, if you look at our schematic, right, we are using pin 13 and pin 12 as our inputs and pin 11 as our output that goes to our inverter chip. So let's go ahead and we're just testing this for now, okay, to make sure it works before we connect it to the inverter. Okay, so this is going to be an input 13. All right, and this is going to be an input 12, okay? And then 11 is going to be an output. Now, to test that our output is working the way that it is supposed to, we have to build an LED output circuit where we connect an LED to the output, and if it's on, we'll get a 1, and if it's off, we'll get a 0. So if the voltage is 0, the LED won't come on, and if the voltage is 1, the LED will come on. Remember, when you're working with an LED, you have 2 different length legs, okay? The short leg is called the cathode. The long leg is called the anode. The cathode is always going to go to ground, right? It's going to go to it's going to be connected with the resistor that's connected to ground. The anode is going to be connected right at the output of the circuit, okay? So we are going to take this, and this is just to test the output of the chip, okay? So we're going to go ahead and put that there, and we'll just put the leg here, okay? And then we will take a resistor. We are just going to use a 220 ohm resistor. That's a good amount, and that's so that we don't put too much current into our LED. And put that in, one end here, and the other end into ground. Okay, so how does a NAND work? Okay, the way a NAND works is that if any of your inputs are 0, you get out a 1. The only way you get out a 0 is if you have 2 high inputs or 2 ones. Okay, so let's start with 0, 0 as our input. So we're going to put this into ground here, and we'll put this into ground. If we have a 0 and a 0, we have a 1 as an output. That's high. Okay, that's about right. Let's try 0, 1. So we're going to take this input and we're going to put it in power. Okay, we still have a 1. What if we have 1, 0? So let's put this back in 0, and let's take this and make it a 1. We still have an output of 1. That makes sense. Now let's make both inputs a 1. We should get out a 0, and we do. Our LED doesn't come on, so that's a 0. Okay, so that means that our NAND chip, our 7400, is working correctly. So now let's move on to the next stage. Now that we have the NAND working correctly, okay, we need to connect it to an inverter and make sure that it works the way it's supposed to. So first, let's just test our inverter chip. Okay, so we're going to move our little LED output to our inverter chip. Okay, so first of all, let's go ahead and let's connect our inverter chip to power. Every IC you have to power and ground. And let's ground it. Okay. And we ground it. Okay, so now it's powered and grounded. Okay, so the way an inverter chip works is that you have an input and an output. So let's see really quickly which pins are inputs and which are outputs on this chip. So if we look at a data sheet, we will see right here on this side, since we're working on that side, let's just continue, that pin 13 is an input and pin 12 is an output. So we're going to use 13 and 12. Okay, so let's go ahead over here and let's test 13 and 12. Okay, so I am just going to use, so remember, we're going to hook up our LED to test, right? So our anode is the long end. It's going to go into pin 12 here, and then it's going to go somewhere else. And then it will connect to a resistor. Once again, we'll just use a 220 ohm resistor to connect in. And then that will go to ground. Okay, so that's our output. So let's test our inputs. Okay, so our input is pin 13. All right, so let's test an input of 1. If an input is 1, your output should be 0. It should be the opposite for an inverter chip. So we are getting a 0. So now you have to be careful with these legs of the LEDs. They can be very twisty. Now let's put a 0 on our input, and we should get an output of 1. So if I put a 0 on there, the LED lights up. My output is 1. Okay, so my inverter is working the way it's supposed to. Very good. Let's move on down to our switches. Okay, so instead of just using a hard 5 volts and 0 volts, we are going to incorporate switches and switch between 0 and 1 without having to keep changing our wires from a physical 0 and 1. Okay, so remember, to hook up an inverter, to hook up a switch, there are several things that has to happen. First of all, on the side that says on, right here, you see where it says on, that has to be hooked up to 5 volts. Okay, so we're going to use switch 1 and switch 4. So we're going to hook 1 up to 5 volts, and we're going to hook 4 up to 5 volts. Okay, so both of these. Okay, now on the other side of the resistor, what you have to put is you have to put a pull down resistor on this. So you have to pull the voltage down to 0, and you have to use a resistor to do this on the other side. So we are going to take, this is a 220 ohm resistor. We're going to put that here on switch 1, and we're going to put that into ground. Make sure it goes all the way to the bottom. And then we have another one. Actually, we're going to use this one because we need, this is only 100 ohms. We're going to take the 220 ohm one. So we're going to take that out, and we're going to put this in pin 4. Switch 4, right? And then we're going to put that to ground. Okay, and now we need to know whether or not our switch is on or off, right? So we're going to use LEDs to tell us that, okay? So once again, we're going to take a LED. We're going to take the anode, which is the long end, which is this end right here, and we're going to put that here. And then we're going to put the cathode, the short end, into ground. And then on this side, the same thing. We are going to put the long end, the anode, into the same electrical connectivity row for switch 1, and we'll put the end in ground. Okay, so let's test out our switch. Okay, so right now they're both off, right? And nothing is lighting up. So let's turn this on. That lights up. Okay, if I turn it off, it turns off. Let's look at switch 4. Right now, it's not on, and the LED is not on. I turn it on, and the LED turns on. So our switch is working correctly. So now let's connect our switch to our NAND gate. One switch is going to go to pin 13. The other switch is going to go to pin 12, and then the output from our NAND is going to go to the input of the inverter, which is switch 5, and then the output of the inverter is going to go to our very last, we need another LED. Oh, so I guess we did need that LED we had there. So I need one more LED and resistor. So here we go. We have a LED. So the output is going to be pin, well, we were using pin, okay, so we're supposed to be using, okay, so let's go back to our NAND gate. So input 1 is going to come from, all right, and then our other input is going to be connected over here. Okay. All right, then our output is going to go to pin 5 per our circuit schematic, right? Right here it says it's going to go to pin 5 on our inverter. All right, so we're going to take this output from 11 and take it to pin 5. So that's 1, 2, 3, 4, 5. Then the output from the inverter is pin 6. Okay, so from there, we are going to put our LED so that we know if everything is working the way that we want it to work. So remember, our anode is going to come from here, and it's going to go, it needs to be connected to a resistor so we don't burn our LED out. All right, so we put that there, and then we take a resistor and we go from here to ground. Okay, so now everything should be set. So let's see if it works the way it is supposed to. So let's see what's supposed to happen. Let's go through our truth table. 0, 0. So right now our switches are on 0 and 0, and our output should be 0, and our output is 0. Now let's try 0, 1. So this input is a 0. This one is a 1. That lets us know this input is high. It's a 1. But our output, which is right here, is still a 0. So that's good. Let's try 0, 1. We look on our truth table. 0, we already tried 0. 1, 0. 1, 0 should give us a 1 as well. So let's try 1, 0. Okay. Now this switch is on. That's what this LED tells us, but the output is still 0. Okay, so that's true. Now the last row is both inputs are 1. So let's put both inputs as 1. And then look, our output is high. It becomes a 1. Okay, so we have built the circuit correctly. And it is working the way that it is supposed to work. So, all right, this is what you will do in the lab yourself. So I hope this video helped. Bye.